All right. So now let us try to do 10.3. Let's read the statement carefully before we can do the calculations. Reading the statement carefully is very important. So now, a laboratory technician wants to determine the concentration of hydrochloric acid sample. A laboratory technician wants to determine the concentration of hydrochloric acid. That means I expect the question to say calculate, which is this, calculate the concentration of the hydrochloric acid sample. So that means a lab technician, meaning in this case, for a fact that we do not know the concentration of hydrochloric acid, that means in this case, hydrochloric acid, we cannot name it as a standard solution. A standard solution, it is a solution with a known concentration precisely. So that means in this case, hydrochloric acid is not. Just saying based on the basics. Now, okay, after this is what a lab technician wants to do, right? To determine the concentration of this. He adds 5 cubic centimeter of the hydrochloric acid sample to 495 cubic centimeter of distilled water to give 500 cubic centimeter of dilute hydrochloric acid. Okay, remember, what did I say to you? The moment when you come to this term here, distilled water, what are we actually doing? We are actually diluting. So that means hydrochloric acid, in this case, it is concentrated. So the moment when this guy weighed a 5 cubic centimeter, he just weighed a 5 cubic centimeter. He took only, maybe he pipetted. So he just weighed 5 cubic centimeter into this water. We have a huge dam of water, but then he just decided to go with 5 from here. He just decided to go with 5 cubes. This is a pure dilution. This is a great dilution. And therefore, obvious, this 5 plus 4, 195. Therefore, the volume will most definitely increase to 500 cubic centimeters. Okay, I see this guy, how is he moving now? So now, during a reaction of 50, okay, this is what is happening. I agree we weighed this and then we made 500. We made 500 cubic centimeters. Now, out of this diluted, remember, we have concentrated hydrochloric acid. We have in this solution, we have diluted hydrochloric acid. Here we have concentrated, here we have concentrated hydrochloric acid. Here we have diluted hydrochloric acid. The number of moles in these two different containers are the same. The difference is volume and concentration. Okay, the higher the volume of distilled water, the lower the concentration. So in this case, this is concentrated and this is diluted hydrochloric acid. That's very important. Now, from this diluted solution of hydrochloric acid, we only going to take from 500 cubic centimeter, we are only going to take 50 cubic centimeter. So that means during a reaction, 50 cubic centimeter of this dilute hydrochloric acid solution reacts completely with 0.29 grams of sodium carbonate. So that means in this speaker now, we have what you call the sodium carbonate with known mass. Now, this sodium carbonate, according to this balanced chemical equation, the sodium carbonate will react with that diluted hydrochloric acid to form these products, which is salt, carbon dioxide, and water in liquid form. Now the question says to us, calculate the concentration of the hydrochloric acid sample. And this is what I want you to know. We want to know the concentration of hydrochloric acid in this case whereby hydrochloric acid was concentrated, because initially a lab technician wants to determine the concentration of hydrochloric acid, and then he add 5 from this unknown hydrochloric from this hydrochloric acid which has an unknown concentration. Does the statement make sense to you, Dimpo? Right. Now, let us do the calculations. So now, according to this balanced chemical equation, sodium carbonate will most definitely react with 2 molecules of HCl. I'll just leave the states out, to form sodium chloride, 2 molecules of sodium chloride plus carbon dioxide plus water. Right. Remember here we used a diluted hydrochloric acid, HCl. Do not forget that. Now, what volume of diluted hydrochloric acid did we use? Now we used 50 cubic centimeters. Remember that, right? We weighed this volume of 50 cubic centimeters into this substance, which is called sodium carbonate. But remember, most of the times we convert our units to cubic decimeter. We divide by 1,000. We're going to say 50 divide by 1,000. And then how much do we get? We get 0, 0.05. We get 0, 0.05 cubic decimeters. This is our volume of diluted hydrochloric acid added to this. Now, I want for a fact that you are told that, I love this. During a reaction, 50 cubic centimeter of this dilute hydrochloric acid solution, which is HCl, reacts completely with this 0, 0.29 grams of sodium carbonate. So that means we have a limiting reagent because it reacts completely, all of it. So that means in this case, our sodium carbonate, we are provided with its mass only, and then the mass of our sodium carbonate, it is most definitely 0.29 grams. So we're going to use this reactant to determine number of moles of HCl, but I'll tell you why. Okay, so now remember, in our minds we want to determine the concentration of hydrochloric acid. But do not forget, we do not want concentration of diluted hydrochloric acid. Rather, we want the concentration of the concentrated hydrochloric acid. Right, now this is what we are going to do, okay? From this, before we do calculations, let me tell you what we are going to do. We are going to determine number of moles of sodium carbonate. How? By using mass and molar mass from the periodic table, meaning we're going to perform stoichiometric calculations using this formula. Number of moles of sodium carbonate, which is mass over molar mass. And therefore, this number of moles, they're going to help us to determine number of moles of hydrochloric acid. Now, this number of moles of hydrochloric acid, remember again, this is what I want you to understand. This is what I want you to understand, and this is what I said. I said number of moles of hydrochloric acid in this diluted hydrochloric acid is the same as number of moles of this diluted hydrochloric acid. So that means this is what we are going to do. After determining number of moles of 50 cubic centimeter, which is this, remember, this is 50 cubic centimeter. This number of moles, we're gonna number of moles under this volume to determine the concentration of this. And therefore, volume and the concentration, which is number of moles, is going to be the same, because remember, volume multiplied by concentration multiplied by volume, it will yield from this formula. Let me write it over here. C is equals to N over V, and then that means number of moles is going to be C multiplied by V. So that means C multiplied by V, it's a concentration of hydrochloric acid in this, and then the volume of the whole solution in here, it is, I'm gonna call it number of moles. So that means number of moles in here supposed to be the same as number of moles in there. We use the same number of moles, it's just that the volumes are different. That means the concentration will also be different. Right, let us do calculations. Maybe it will make much more sense. So let us determine number of moles first of sodium carbonate. So what is the mass of sodium carbonate? It's 0.29 grams, and therefore the molar mass, remember our sodium from the periodic table, it's 23. So that means we're gonna say 2 multiplied by 23 plus carbon, it's 12, and then oxygen, we know that it's 16. We're going to be 3 multiplied by 16, right? So we have this, and therefore let us determine number of moles of sodium carbonate. So on our calculator, we're going to say 0.29 divided by 2 multiplied by 23, multiplied by 23 plus 12 plus 3 multiplied by 16. Then when I punch this on my calculator, this is what I get. I get 2, to 2 decimal places, 2,74 times 10 to power -3 moles. Okay, so this is the number of moles of what? Of sodium carbonate. Now let me help me to determine the number of moles of that. According to a balanced chemical equation, I'm gonna use the stoichiometric coefficients of my substances. So here I have 1, and then for hydrochloric acid I have 2. And therefore, how many number of moles of sodium carbonate do I have? I have 2,74 times 10 to power -3 is to how many number of moles of HCl? That's what I'm looking for. I'm looking for number of moles of a diluted HCl, not concentrated HCl, and then I cross multiply. I'm going to say 1 multiplied by that. I'm going to have 1N of diluted hydrochloric acid, which is going to be equals to 2 multiplied by this. I'm just going to say this answer, okay, but let me just to 2 decimal places, 2,774 times 10 to power -3 multiplied by 2, and therefore it happens that my final answer, is 5,48 times 10 to power -3 moles. Okay, right. So this is my number of moles of diluted hydrochloric acid. Remember here, I get here. This is what is basically happening, because now after determining my number of moles here, this is what I'm going to do now. This is what I'm most definitely going to do. I am going to determine the, remember, I want to know the concentration in here. Okay, what will be my concentration in here, right? I'm gonna say, let's start here by determining this concentration. So, Kamanzwaman, this is what I'm going to do. I'm going to say C is equals to N over V. Now, what is my number of moles? My number of moles is gonna be 5,48 times 10 to power -3 divide by what? This is my number of moles, remember? My volume, which is 0,05 cubic decimeters. And therefore, when I punch this on my calculator, how much do I get? I'm going to say my final answer, divide by 0,05. I I get my concentration to be 0,1096 mole per cubic decimeters. Oops, decimeters. That will be my concentration. But remember, which concentration? Concentration of this diluted acid in this case, right? But remember, concentration, yeah, 50 cubic centimeter, it is not the same as concentration of 500 cubic centimeters. So that means this is what I'm going to do. I'm going to determine concentration here so that I can know my number of moles because I know the volume already, right? So, but now how am I going to do that? I'm going to determine the number of moles. So now, let me do this. So now this is what I'm going to do. I know my concentration, therefore let me determine number of moles using this volume. So that means I'm going to say my number of moles is equals to C multiplied by V. So now my concentration, it was 0,1096. 0, let me take a pen. 0,1096, and therefore my volume in this solution is 500 cubic centimeter. So I'm gonna convert it, this 500 cubic centimeter into cubic decimeter. When I convert it, it's gonna be let me see, it's gonna be 0,5. It's gonna be 0,5. 0,5. And therefore, let us determine number of moles in this solution. How much is it? So that means I'm going to say my answer multiply by 0,5. And therefore, how much do I get? I get that my number of moles is 0,0548 moles. Therefore, this is number of moles in this huge container. But remember, I said to you, number of moles in this container is the same as number of moles in that container. But now here, I'm going to use a volume of 5 cubic centimeters. So that means I'm going to say number of moles of HCl concentrated. This is number of moles of HCl diluted. Do not forget, please. This is number of moles of HCl diluted. So I'm going to say number of moles of, let me write it in this way, number of moles of diluted, oh my God, diluted HCl is going to be the same as number of moles of concentrated HCl. So what is the number of moles of diluted HCl? It's 0,0548. And therefore, what is the calculations? I do not know them, but I know how to calculate this. It's C multiplied by V. So remember, this is the concentration that I'm looking for, because remember, we want the concentration of the concentrated HCl, which is in this container. So that means, but how many volume, how much volume did I use? I use 5 cubic centimeter of this concentrated HCl. So that means I'm going to say here I have C multiplied by volume. I'm going to say 5 divided by 1,000, converted to cubic decimeter. It's going to be 5 times 10 to power -3. Close my bracket, and then here I have 0,0548. Therefore, I divide both sides by 5 times 10 to power 3. I'm going to say 0,0548 divided by answer. How much do I get? And then I get that my concentration of concentrated acid is 10.96 mole per cubic decimeters. Does it make sense? Dimple, does it make sense?
No, I don't understand. I'm lost.
You are lost. There is nothing to be lost here. Right.
Yeah, so what I don't understand is when we calculate when you first calculate, I think I confused. I get it diluted and concentrated because we've never done it like that. So I'm just confused.
Okay, please listen carefully. You understand the statement. You understand the statement 100%.
Yes, I understand the statement.
All right. You know what is happening here, right? Here, Shevadimpo, let me use a pointer because I have already written everything. So, check. Here, we have the equation, right? But this equation is taking place where? It's taking place in this beaker. Right? In this beaker, we have sodium carbonate and we have a volume of 50 cubic centimeter of hydrochloric acid. But do not forget, this volume of 50 cubic centimeter of hydrochloric acid, it is diluted. It is diluted because this solution, it was mainly composed of distilled water and a smaller portion of concentrated hydrochloric acid. Hence why we say in this solution of water and HCl, it is a diluted hydrochloric acid. So that means in this, Bona, we have 500. We just took only 50 from 500. We only took 50. And this 50, okay, but 50 of HCl, which is diluted, remember, it's from diluted beaker, hence why we say it's a diluted one. 50 cubic centimeter, right? This 50 cubic centimeter, which is diluted hydrochloric acid, it is going to react completely with sodium carbonate in this beaker, which is a reaction of this and this, but the mass of this sodium carbonate is 0.29 grams, right?
Yeah, so can I ask Dr. Sebone?
Yes.
There, where you calculated the number of moles of HCl using the mass of Na2CO3, ne? Since HCl is the limited reactant,
no,
you
it's
can't
not.
calculate.
Read, I understand. I see how you read it. They say, where is it? During a reaction, 50 cubic of this hydrochloric acid solution HCl reacts completely with 0.29 grams of sodium carbonate.
Oh, so that means that even the sodium carbonate also reacted completely.
Exactly. It's a limiting reagent, this one.
Oh.
Because they can't just
I
give
get
you
everything.
mass and not calculate the number of moles. That means this number of moles using the mass of sodium carbonate and molar mass of sodium carbonate, this number of moles, basically, this number of moles, it's a number of moles of sodium carbonate. So this, they're going to help us to determine number of moles of hydrochloric acid. Are we on the same path?
The thing is, we did a similar question kat last time, but it thing the HCl was the limited reactant, and then they gave us the mass of the other one. Then it was a struggle to get the actual moles of HCl because it meant that the ratio wasn't 1-to-1 anymore. The ratio was something else to something else because they said that one of them is a limited reagent. So I got confused. So when they say that sodium carbonate reacted completely with HCl, does that mean they both reacted completely?
Yes.
Oh. Can understand
that. So that means from there, we know here how to determine number of moles of HCl, right? And this, it's number of moles of HCl. But which number of moles? This number of moles of this HCl. And do not forget, this is the diluted HCl, but only 50 of it, not 500, only 50 of it in this reaction, right? Right. You know now, this is what we are going to do. After determining number of moles of HCl, we're going to use this volume and this number of moles to determine the what? The concentration of the very same HCl. Right? So now we find out that the concentration of the very same HCl is this one over here in mole cubic decimeter. This is the concentration of the very same HCl. Right. Now we are done. So now after determining the concentration of this HCl, now listen. I'm saying to you, look, I'm saying to you, are you listening? Number of moles is the same as from here to here. What is the volume here? What is the volume of here? Here we have 50, right?
Yeah.
What is the volume here? Here we have 500, right?
500 centimeters cubed.
Right. So that means diluted. Limo, we use diluted. Don't forget that. Diluted HCl, diluted HCl. They have the very same number of moles. It's just that the volumes are different. That means the concentrations also it is going to be different. Right? So that means I use this volume, I use this number of moles to determine the concentration of this diluted HCl in here. So this concentration, it is going to help me to determine number of moles here and number of moles there.
Okay.
Because do not forget, okay, my man, this number of moles, it is the reacted number of moles of diluted HCl. Don't forget that. This is the reacted one, okay? So here, but before the reaction could take place, like determine this number of moles, it's this number of moles that I'm talking about. So we use the concentration, we use the volume of 0.5 or this one. So that means we use the concentration, we used the volume to determine number of moles in here. Now, this number of moles of diluted HCl is the same as number of moles of concentrated HCl.
Concentrated HCl, okay.
That's why I said number of moles of concentrated HCl is going to be the same as number of moles of diluted HCl in these two, because the difference is here we have a volume of 5 and then here we have a volume of 500. That means, again, the concentrations are most definitely not going to be the same. Hence why I equated this to that. Right?
Okay, I understand now. Understand.
Right.
Because the number of moles is the same. So then you just use the 0.0548 equal to C times V.
But remember, this is the number of moles of diluted, which is what we have just calculated, which is this, like I said, which is this number of moles. So number of moles Sagamo, they're going to correspond with number of moles Sagamo, which is this. So you just plug them here because you calculated them. But here you know that you are looking for concentration. You do not have them to start with. So that means we're going to present this in terms of C multiplied by V. And therefore concentration is what you're looking for of that concentrated hydrochloric acid. And then the volume of that concentrated hydrochloric acid, you just took only 5. Hence why here we're going to substitute 5, which is divided by 1,000, converted to cubic decimeters, 5 times 10 to power negative 3. And therefore, voila, you get your concentration. Does it make sense?
Yeah, it makes sense because, okay, yeah, I understand.
100%. As long as you understand, then I'm the happiest guy ever in this world.
Oh, I get that 5 times since the power of negative 3 is the one that the volume of the...
It's 5.
Yeah.
Yes, it's this one.
Let me just zoom out because I was zooming. Can you please show me the question again?
Okay, let me just